Hi, my name's Matt, and my problem is the air ambulance reassignment problem. The problem states that an air ambulance service provider has several locations. Each location houses an allocated number of helicopters. After a certain time period, the projections are created for each location based on the demand for more or less helicopters. There is a cost to transport helicopters from each location. The question then asks, what is the most optimized route to relocate the allocated helicopters to the correct location? Next, we will look at the individual components of the problem, which will be used in its mathematical formulation. Firstly, L represents the set of air ambulance locations. The parameters of the problem are as follows. The x-coordinate of each location represented as x. The y-coordinate of each location represented as y. The projected demand for the next period for the location represented as d. The number of helicopters currently assigned to the location represented as s. The transportation cost per kilometre represented as c. And the distance between two locations represented as dist. The variables for the problem are the number of helicopters to be moved from location I to J, represented as Z. To create the optimum route to relocate each helicopter, we must use the following equation. We must minimize the sum of all movements between locations by multiplying the distance between the two locations, multiplied by the transportation cost, multiplied by the number of helicopters to be moved. Looking at the example to the right, we can see that the most optimum route is by sending two helicopters from A to C and one helicopter from C to B. This problem, of course, becomes more interesting when there are a greater number of locations and helicopters. The air ambulance reassignment problem can be used in many different applications that involve allocating resources between locations, where there is a cost to moving the resource between locations. One example of the way the problem could be applied is when allocating farming equipment such as tractors between different properties. Another application of the problem could be applied when deciding how stock is distributed between different retail franchises. Finally, the problem could be used to allocate the number of taxis to be located at each different taxi rank in a city. Thank you for watching my video. Please find below my reference for the content.